Okay, hi everybody. Welcome to Geospatial Data and Mapping in Python. So first I'll start by introducing myself. So my name is Eric Perper, and I work in the Brown Science and Engineering Library here at UVA. You might also have heard the library referred to as Clark Library because it's in Clark Hall, but technically the library is called Brown Science and Engineering. So I'm part of a group called Research Data Services, and basically the purpose of Research Data Services is to help with the research lifecycle. So we help people with data, everything from data through publishing and making their papers and things accessible after they've done a publication or something, or a research project, something like that. So part of what we do is we teach workshops like this one. So this is a part of our workshop series. We teach these workshops every semester, and we teach them on a bunch of different subjects. So we offer workshops on programming languages like Python and R in particular. We also have workshops on statistics and then other various softwares. We teach workshops on citation management, like using Zotero and things like that. So I have a link here in the Github page that I'm sharing with you here. And I'll have a link to this Github page in the video notes for this video. So every semester we teach lots of workshops. I have a link to that here as well on a bunch of different subjects. And we tend to front load them towards the beginning of the semester because people tend to attend more, and towards the end of the semester, they're busy with projects and finals and things like that. And the last thing I will plug really quickly is the StatLab. So the StatLab is a service that we offer. So just like we teach workshops on all of these subjects, programming languages, statistics, various other softwares and things like that, you can also set up meetings with us. You can contact us via email or do a Zoom meeting or come to our in-person office hours or do an in-person meeting. So we'll help you whatever way we can. And we have a contact email address here, statlab@virginia.edu. I will also include that in the video notes. So if you're having trouble with your data visualization, cleaning your data, doing statistics on your data, etc., feel free to reach out to us in the StatLab. Okay. So I'm also teaching some other Python-related workshops this semester. This is for the spring 2024 semester. So if you're watching this some other time, this could be outdated. But the rest of the workshops should be mostly the same. So let's get back into the subject matter for this workshop today, which is Python and geospatial data and mapping. So first of all, my background, just a little bit on that. I've got a background in GIS, which is an acronym for Geographic Information Systems. And traditionally, GIS users have used specific GIS softwares such as ArcGIS or QGIS. And those are used to basically put data on the map. That's essentially what they do. There's a lot of other stuff you can do with it. But now I find myself using those less and less and using Python in order to plot things, to work with my data, etc. So you don't necessarily need to learn a specialized GIS program anymore. You can do it in Python. So now there's a full stack of libraries in Python, such as Pandas, MatPlotLib, NumPy, GeoPandas, which I'll be talking a lot about today, and more, which is really nice to just do it all in one Python workflow. And I think maybe you'll get a better idea of what I'm talking about later. Meaning, I guess to summarize that, so a lot of my projects that I work on, either for like internal library projects or when I'm helping people with their own research projects. So those people have data, or those projects have data along with them. So a lot of times you're cleaning up the data, you're manipulating the data, things like that. And then now straight in Python, I can map this data, I can visualize this data, and it's gotten really dynamic now. And now I don't, like I said, I don't need to use an external program. I can just do it all in Python, which is really sweet. So a library that we'll be focusing on today is called GeoPandas. So GeoPandas is basically just an extension of Pandas. So you may be familiar with the Pandas library, which is used for data analysis, data cleaning. It's like it's commonly used data analysis library in Python. Well, GeoPandas is an extension of that. So it tells you here on the GeoPandas homepage that GeoPandas is an open source project to make working with geospatial data in Python easier. And GeoPandas extends the data types used by Pandas. So I will talk some more about that as we go through. Excuse me. And then geometric operations are performed by Shapely, which is another library, and Fiona for file access. We won't really touch much on Shapely and Fiona today, but those are underlying libraries to GeoPandas. And then our plotting happens in MatPlotLib. So this is another commonly used library that interacts nicely with Pandas. And you'll see how we can work with our data in GeoPandas and then plot it in MatPlotLib. That's really awesome. So I might reference the documentation a bit throughout the workshop today, but we'll come back to that. And then another library I'll touch on very briefly at the end is Folium. And this is basically a JavaScript-esque mapping library. So if any of you have done web mapping or anything in JavaScript, this is basically Leaflet, but for Python, which is, Leaflet is a mapping library that's widely used in JavaScript. Well, now we can do it in Python, and that's really sweet. It looks different than, I guess you'll see more as we get there, but it's an interactive web map, just like you would get with Leaflet, but now you can do it in Python. So that's pretty awesome. So I'll come back to this last section at the end, self-help. We'll touch on that at the end of the workshop. Okay. Oh, excuse me, I've got the yawns today. Okay, so we're going to download the code now for this workshop. So I've got, in this GitHub repository, I've got some files. The main one that we'll be working with is this Python Geospatial Workshop file, but I've also got some GIS data from the city of Charlottesville. And you'll see this as we go through the workshop. I downloaded all this data from the city of Charlottesville, which I'll show you later. And these are commonly used geospatial data files. So there's things like GeoJSON, GeoPackage, shapefile, CSV file, etc. So I use a variety of different file types on purpose because I want to show you can work with any normal geospatial data file, and even CSV file, which is basically just a tabular file format, but these points have some geospatial properties in them. They have X and Y coordinates. So let's download this data, and the way to do that is here in the top right of the screen, there's the green code button. And so if you click on that, then you can download zip. And you see this goes to my downloads folder. I downloaded this a few minutes ago preparing for this workshop, so you might see it twice. But anyway, let me open that. And I'm going to drag and drop my folder just onto my desktop like this. So you don't have to do that. You can keep it in your downloads folder. I prefer to keep temporary stuff like this on my desktop because it's easy to find and easy to get rid of later when I don't need it. So now I will unzip the folder, and you can do that either by double clicking. So I'm on a Mac. You can definitely double click on a Mac. Otherwise, you can right click and open with the archive utility. Or if you're on a PC, you can right click and you can extract. I think the button says extract or extract here. So in our folder, it's called Python Geospatial Workshop -main. There it is. Same files and stuff that you would have seen in the GitHub repository.
Okay.
Where was I? Oh yeah, so now I will open Anaconda. So we're going to use Jupyter Lab or Jupyter Notebooks today. If you have not already installed Anaconda, I will provide a link to that here in the video description. I've got this docked, so again, I'm on a Mac. I've got this docked down here at the bottom because it's something I use a lot. But otherwise, on a Mac, if you go to the Finder window, or a Spotlight, I should say, and you look for Anaconda, it should be called Anaconda or Anaconda Navigator. If you're on a PC, look in your Windows Explorer down in the bottom left of the screen and look for, again, search for Anaconda, and you should be able to find that. And if you haven't installed Anaconda yet, you can pause the video. It takes about 15 minutes to install. Or if you're using Jupyter Lab or Jupyter Notebook in another, if you have it installed some other way, that's fine as well. Just really quickly, a brief overview of Anaconda. So basically, Anaconda is a collection of data science and programming related softwares. When you open up Anaconda, this is the dashboard or the navigator, I guess it's called. Yours might look slightly different than mine depending on when you install this, but they've got softwares like RStudio, PyCharm, that's an editor for Python code. Spider, that's another one that I use, another editor, and various other softwares. But today we're going to be using Jupyter Lab. So I'm going to launch Jupyter Lab, but I will also say that if you have trouble for some reason with Jupyter Lab, you can also launch Jupyter Notebook, and this will run exactly the same as far as I can tell. So I will launch Jupyter Lab. And sometimes it takes a few minutes for both Anaconda and Jupyter Lab to boot up, depending on how recently you've used it and stuff like that. Okay, so Jupyter Lab is web-based, so you will see this pop up in a browser tab in your web browser. So let's go back. So when this opens, it'll probably look something like this. So there's a little tab up here in the top left for file browser. And remember, so this navigates just like a normal file browser window. So remember, I've moved my folder to my desktop. This is the stuff that I downloaded. So this is called Python Geospatial Workshop-main. So if I open that, and then I can open the Python Geospatial Workshop.ipynb file. And that ipynb, that stands for IPython Notebook. I won't go into that, but open up this file, and you can close that tab if you want. And this is what you get. Okay, so if you are new to Jupyter Lab or Jupyter Notebook, this is what it looks like. It's basically, I think of it like an interactive blog post. So you have text and you have code. So these code cells, these are called cells, are in gray. And this is code. So I'm going to run one of these for you. And the way I've got this set up is I've marked these steps throughout the workshop. So step 1 is basically just installing the proper libraries and then importing them. So the way you do, so this is actually live code. I can add stuff onto it if you want, or if I want to, and then I can rerun it. But basically, the way to run a cell is to click in the cell, and then you can click on the play button up here or the run button, or you can click in the cell and shift enter? Yeah, shift enter or shift return. So long story short, let's start here at step 1. These first 2 cells I'm not going to run these because I've already installed these libraries. So if you run these, it might take you a few minutes for you to install these libraries, including GeoPanda, Descartes, and Contextily, also Folium. So if you, especially if you aren't able to install Descartes or Contextily, don't worry too much about it. Those are nice to have, but not mandatory. And then the second one here, pip install Contextily and Folium. I've also got a caveat here. If this part doesn't work, then you can try this here. And I won't go too far into what we're doing, but just know that we're installing these libraries. Again, it'll take you a few minutes to do if you have not installed them before, and you'll get a lot of output below these cells. So don't worry, that is normal. You might even get some errors, especially regarding the Descartes or the Contextily libraries. But anyway, I'm going to skip straight to this cell here with all the import statements because I have installed these libraries already. So basically, I'm importing these into the namespace for this workshop. Okay, so let's go down here to step 2. So before we really get into the code that we're doing today, we're going to set up our file path. And this is not required, but it's a nice to do thing. So let me back up here, go to my desktop, and I'll go to the Python Geospatial Workshop -main. So again, these are the files that we downloaded from GitHub. And the data that we're working with today is in the Cvil GIS data folder. And that's inside Python Geospatial Workshop main folder. So setting up my file path, basically we're going to be using that data from that Cvil GIS data folder. And this is just creating a variable which stores the file path to that data. So you'll see how we're using this later. So go ahead and run step 2, and there's no output there, so it shouldn't give you any. But you'll see how we're using that later. It'll save us some time. Okay, so before we get into this, I'm going to do a really quick refresher on pandas if you're an inexperienced user. If you're an experienced user, just skip this quick step 3. But anyway, so this is a pandas data frame. So the pandas library, let me run this for you and show you what it looks like. A pandas data frame looks like this. It is a two-dimensional spreadsheet, if you will, like a two-dimensional tabular data format. It has columns, which go vertical. It has rows, which are the horizontals. The rows are indexed, so they're numbered and ordered. So you see row 1 is index 0, row 2 is index 1, and so on. So what I've done here is that I've just created a really simple pandas data frame, just some dummy names and ages, and then created a data frame called df, and then I printed it. So this is what a data frame looks like, and this is the object that we're basically going to be extending using GeoPandas. Okay. So getting into the content for the workshop today. So I briefly introduced GeoPandas earlier. I've got a link again to the documentation for GeoPandas. So like I said, GeoPandas is basically an extension to the pandas library. And the difference here is that basically a GeoPandas data frame, I'll show you that next, it is a pandas data frame, except it has a special column which contains the geometry of an object. So we'll see that next. And this is what allows you to do the mapping, plotting, and geospatial operations all within Python. So there's no more mixing between other programs. So real quickly, just a note on today's data sources. I've got all of our data from the Charlottesville City Open Data Portal. I think I also got some from Richmond. That's later towards the end. Most of this is publicly available data from the city of Charlottesville. So the city provides this data for free for people to use for various purposes, such as this one. So go ahead and check that out sometime. You can click on something and it'll give you, I don't know, city trails. Let's take a look at that. And this is what you'll see. It's the data plotted on a web map. So you can see these trails in here. There's the rail trail at Water Street, the Rivanna Trail, some unnamed trails in here, Washington Park Connector, etc. So these are all the trails in and around Charlottesville, also the Ragged Mountain trails up here. And you can download this data, and then they give you a variety of data formats to download it in. So as I showed you quickly earlier, I downloaded basically one of all of these: GeoJSON, shapefile, KML, CSV. And if you're not familiar with those data formats, don't worry, I'll talk about them as we go. But anyway, this is where I got the data from, the City of Charlottesville's public data page. Okay, step 4. Okay, so we're reading our first data set here. So this is a GeoJSON file. So GeoJSON, this is basically just structured text. If you look at the raw data of a CSV file, that means comma separated value. It's basically just structured text. All the data in the file is separated by commas in a structured way. Well, GeoJSON is just a different style of structured text. JSON stands for JavaScript Object Notation. That's in JavaScript, the language, different programming language. There's a data type called an object, and the notation of that is basically equivalent to a Python dictionary. So this data basically looks like a Python dictionary, except that it's got things like X and Y values or latitude, longitude values in it. So in step 4, we're going to read in our Charlottesville boundary layer. So you can see what I'm doing here. Earlier, I imported GeoPandas, and that is called GPD. So commonly in pandas, you see that as PD, so GeoPandas is GPD. Okay, so GPD, and then we're reading a file. And then basically, this is just my path to the Charlottesville base map layer. So if I run that, you see it takes a minute to run. And remember, to run a cell, just click in the cell and then click either the run button, or your keyboard shortcut is Shift Return or Shift Enter if you're on a PC. And now we're going to plot this layer. And this is just MatPlotLib. It's really awesome how they basically used or modified the MatPlotLib functionality to be able to plot just as you would a normal MatPlotLib bar chart or line chart or something like that. So if you've used MatPlotLib before, this will probably look familiar to you. This is basically just what MatPlotLib looks like. Don't worry about the axis labels yet. I'm going to talk about those next. But those are degrees of latitude going north and south, and longitude going east and west. But anyway, you see the shape of Charlottesville here. And if you didn't know, this is what the city boundaries of the city of Charlottesville look like. Awesome. Okay, so let's talk about a GeoPandas GeoDataframe. So in GeoPandas, the GeoDataframe is the common data type or data object type. So this is basically just like the Pandas data frame, but with a geometry component. So in step 5, I'm just going to print my data frame from above earlier. So remember, I just did this dummy data frame called DF. It's just some nonsense data really. So what I'm doing is I'm printing the data frame, and I'm printing the Seville boundary, which is a GeoPandas GeoDataframe. I'm printing the type of those. So you see here that they are different object types. The first one is a Pandas Dataframe. The second one is a GeoPandas GeoDataframe. So now let's look inside of this GeoDataframe and see what there is in there. And this one's kind of unruly and unwieldy to look at. But anyway, these are the columns in the GeoDataframe. There's the object ID, FID mask, ID. But basically, the geometry column, this is the key here to the GeoPandas GeoDataframe. So you see here it says polygon Z, and then there's like all these latitude, longitude coordinates. So it goes 78 degrees, negative 78 degrees latitude, so that's 78 degrees west. And I'm going to talk more about this in a few minutes. 38 degrees north. So you might wonder, what the heck is all this? Well, these are all the little vertex points for this shape. So you see there's quite a few of them because Charlottesville is not a clean square or anything like that. It's this strange shape. So these are all the vertices of that shape. And you see here, we only have one row. It says row index 0. We only have one shape on the map. So this is a pretty weird GeoDataframe to look at, but I'll show you a cleaner one later, which will probably make more sense to you. But just remember, this geometry column is really important because this stores the spatial geometry as latitude and longitude points of your shape or your line or your polygon, your point, whatever you may be working with. So that's unruly. We'll go down to the bottom of it. And so like I said, there's a geometry column in the GeoDataframe. So so basically what I'm doing here is I'm making a point that you can use all the same methods and functions as you would with a Pandas Dataframe. So this columns and then to list function here, this is something I do a lot with Pandas Dataframes just to look at what columns are available to me. And it gives them to me in a list. So object ID, FID mask, ID, shape area, shape length, those all come from the city of Charlottesville. So that was a part of the data when I downloaded it. The geometry column, that is what GeoPandas created. And then I printed just the geometry column, which you don't see much of it here, but just know that you can do that just the way you would in a normal Pandas Dataframe column. Okay. So now we're working with roads. So this is a little bit more exciting. Again, we're reading a file and we're reading the road center lines here. So this is a little better look at a Pandas or a GeoPandas GeoDataframe. So I just printed, well, first of all, I read the file and saved that as roads in a variable called roads. And now this is what my GeoDataframe looks like. And this is a little bit easier to wrap your head around. So each row in the column is a road in Charlottesville. And there's 2,709 of them. So they don't give them all to you here. They just give you a snapshot of them. But as you can see here, some of this data is human readable. So the street name, Cleveland, the suffix Avenue, Cleveland Avenue, the speed, 25 miles an hour. The next one is also 25 miles an hour. And then it gives you this line string object. So the geometry of this is a line instead of a polygon or a shape, which you'll see next, right? Because roads are just lines on the map. The rest of this stuff, LLAD and LHAD, I don't honestly know what that is. That was a part of the data set when I downloaded it from the city of Charlottesville. So some of this stuff means nothing to me. It probably means something to the city or to somebody working in a city government. But to me, as the casual user, it doesn't mean anything. So again, like I said, there's 2,709 roads in the city of Charlottesville, apparently. So now I'm plotting this layer again, and you see the outline of all the roads in Charlottesville. So you see here that I'm using this plot method, and this is, again, this is just a MatPlotLib function, if you will. So this draws it on the map, just like in a MatPlotLib map. And this is a static map. We'll talk a little bit more about dynamic web mapping and stuff a little bit later at the end. So just like you can, step 7, just like you can in MatPlotLib, we can plot these layers on top of each other. And we're not limited to just 2 of these layers. You can stack many layers on top of each other. So here is the way of doing that. Let me run this first, and then we'll talk about the code a little bit. So let's see what I did first. So you see here that the roads in Charlottesville are in white. The outline of the city boundary is still in blue. That's just the default. So I did a few different things here. First of all, you might, if you're a MatPlotLib user, this setup might be familiar to you. This is how you set up multiple plots in one like map, or if you will, or one chart in MatPlotLib. And I have a link here to the documentation page for exactly how to do this. So I wrote a little comment here. Why did I write it this way? Because the documentation told me so. So I've got a link to the documentation page. Whoops, there we go. So control the orders of multiple layers in a plot, and it gives me a little code snippet. And then if I scroll down, it'll give me some more. So it's showing you how to do this directly from the documentation. So I basically copy and pasted this straight from the docs. And I did a few other little things here. I made the figure size bigger because it's just nicer to look at. I made the edge color black, so you might see this black border around the city of Charlottesville. And then I plotted the roads as white. So I could change that. I could do it in red. So that's kind of ugly to look at, but you see my point. I could make these all kinds of different colors if I wanted to. So there's a lot of these arguments or parameters in these functions, in the plot function here. Okay, so we're going to add a base map now. So again, I found this code from the GeoPandas documentation. So we're using the contextile library to do this. And adding a base map, again, is not required, but it does make it nice because it gives some context to your map a little bit. Whoops. Okay. Maybe we won't be adding base maps today. I've actually had some trouble with the contextile library in the past, so if it doesn't work, then we're all in the same boat together. But let me go to this code in the GeoPandas documentation. So adding background maps to plots, or base maps as you might call it. So basically what I did is I just copied a code example from the documentation. So you see they've got, let me make this smaller. They've got just a base map. This looks like New York City, I think. Yeah. And they are eventually adding a base map to it here. If I scroll down far enough. This has really changed since the last time I looked at it. You know, it looks like they might not be able to do this either. So actually, I might edit this part out of the workshop, but it looks like the contextile library is no longer playing nicely with GeoPandas or MatPlotLib. So, that's interesting. It looks like the documentation itself is also not working. So I guess we won't be adding base maps throughout the rest of the workshop. So just scratch what I said earlier. A base map is basically just like a satellite view, background imagery of satellite imagery. That makes it just kind of nicer to look at, but it's not required. Okay, so the next section here, working with coordinate reference systems and map projections. So I briefly mentioned these numbers on the y-axis and the x-axis earlier. So I'm going to come back to these now. These are lines of latitude and longitude. Okay, so if you're not familiar with that, the Earth is broken into a grid. So latitude and longitude map. Here we go. So here we go. We have lines of latitude and longitude. And these measure the absolute location of everything on the Earth. And it's broken up by latitude and longitude. So degrees latitude measure things north and south of the equator. which the equator runs through the middle of the Earth, right through there. Lines of longitude measure things east and west of the prime meridian. So the prime meridian runs right through here, and it runs through Greenwich, England. So the equator is a pretty natural demarcation of the middle of the Earth, but the prime meridian is totally arbitrary. You know, back in the day, stuffy English people decided we are the center of the world. So the prime meridian runs through Greenwich, England. It also runs through parts of Western Europe, through Africa, etc. So east and west are measured in latitude or longitude. North and south is measured in latitude. So where was I here? Right. So basically, in Charlottesville, we are about 38 degrees north, and we're 78 degrees west. So you might also see this written as negative 78, or you could see it written as 78 degrees west. Okay, so on that note, like I said, two very short explanations of these terms: coordinate reference systems and map projections. Okay, so coordinate reference systems. So just like I said, everything on the Earth has a location, and this is commonly represented as latitude, longitude, or X and Y coordinates. So for example, Charlottesville is located at 38 degrees north, 78 degrees west, or you might see it written this way as well. But this one is more common. So now for map projections. So this is a tricky subject, but basically, though everything on the Earth has an exact location, it's not always represented the same. So this is where map projections come into play. And basically, a map projection is focused on representing various parts of the Earth as accurately as possible. And there are hundreds of map projections, maybe thousands, and they can range in focus from parts of individual states, North America, the Eastern Hemisphere, Southern Hemisphere, etc., etc. So I'm going to show you a cool site that demonstrates this point really nicely, the true size. Okay. So this is just a cool website that shows you map skew and map projections in reality. So they give you a base map here, and this is just a Google Earth base map that you might be used to looking at. And they give you, I don't know why they give you China turned sideways. But anyway, the point here is that as you're moving things north and southeast of the equator, you are seeing a skewed version of those objects. So the point here is that the map projection being used in this map is focused on representing things near the equator accurately. So as you can see here, if I move the US over top of the United States like that, it's actually smaller than it's represented on the map here. You know, not hugely smaller, but you see the point. And what you can do here, the most egregious example of this is Greenland. So Greenland on this map looks massive. It looks about the size of the continent of Africa. So let me show you what happens when you show the true size of Greenland. So you can type in either US states or countries up here. And then if I move Greenland down over the continent of Africa, you see how big it actually is. It's really just the size of a large country. It's, you know, maybe 1/6 the size of Africa or something like that. So anyway, you see my point here that we're seeing skew in the map as we move towards the poles. And maps always have some kind of map skew. It's basically an age-old question that geographers have been trying to fight with because, long story short, the Earth is a round object, or it's a mostly round object. It's not perfectly round. And when you're representing it on a flat surface like a computer screen or a paper map, basically cartographers or map makers have to make a decision how they're going to represent that as accurately as possible. So these things called map projections are basically making an attempt to do that. And this is a whole, you know, wormhole you could go into. But just know that we are seeing things represented in a certain way in this project and any map you look at, basically. So we have these coordinate reference systems and map projections. So don't worry too much about that. I just wanted to broach the topic because it is important in this case. So in step 9 here, what coordinate reference system, or I guess I should say, what map projection are we currently using? So there's this CRS attribute of a GeoPandas data frame. So if I run that, it prints some information. So you see here that this may look like nonsense to you, but just know that this WGS 1984, that stands for the World Geodetic System. So basically they measured the Earth in 1984 to figure out the latitude and longitude of everything on the Earth. So that's what we're using currently. That's what this layer is represented as when we downloaded it from the city of Charlottesville. So when you download these geospatial layers or map layers, they always have that spatial information captured with them. So I know that was dense and we're getting stuck on a tangent there, but just know that you can change the map projection of a layer. And you might be wondering, why would I do that? Well, it's pretty common in the GIS world to bring in some data from a bunch of different sources. So let's say I had various data about the city of Charlottesville, and I brought in some of the data and it is where it belongs over the city of Charlottesville. But then I bring some other background, other data in, and it's like off in the middle of the ocean somewhere. Well, the reason for that is because they are not using the same map projection. So again, that's a tangent, but I just wanted to at least make you aware that that could happen, and if it does, this is why. So I've taken the liberty here of converting this map projection of the Seaville boundary and the roads layer to something that is a little more Virginia-centric. So again, not to get too far into it, but I've chosen a Virginia State Plane coordinate reference system that measures things in feet. So don't worry about this here. This is just the ID number of that coordinate reference system. So we're changing the Seaville boundary to this coordinate reference system, and we're doing the same for the roads layer. So if I run that, there's no output, but they will have changed. And if I plot my map again, you see that the X and the Y values are different now because these are actually being represented in feet instead of in decimal degrees, which they were represented as earlier. So let's keep moving. Now we'll get into the fun stuff that may be a little more meaningful to you. Okay, so geospatial operations. So this is part of the awesome stuff that you can do now in Python using GeoPandas and MatPlotLib and things. So previously you had to do these in a GIS software such as ArcGIS or QGIS, or a geospatial database such as PostgreSQL. But now we can do it right here in Python. So step 11, I've downloaded a neighborhoods layer. So these are all the neighborhoods in the city of Charlottesville. So let's run this cell here. So I've plotted all the neighborhoods on the map. So you see that it's basically the same outline as we saw earlier of the city of Charlottesville. And now all the neighborhoods are represented as a different color. So what did I do here? I added some more attributes or parameters or arguments, as you might call them. And what I've done is I've labeled the name column. Okay, so let me turn on this thing that I commented out right here. And I did that on purpose because it looks terrible when you actually look at the like underlying data for each neighborhood. But you'll see here that I have this is looking at my GeoDataframe, and there is a name column. So each one of these neighborhoods has a name. First neighborhood, North Downtown. Second neighborhood, Martha Jefferson. Third neighborhood, Woolen Mills. So these are all neighborhoods in the city of Charlottesville. So I will comment that out again just for a second and run this again. So there's like, I don't know, 15 or so neighborhoods in the city of Charlottesville. And what I'm doing is I'm labeling them on the map in a different color, or I should say I'm representing them on the map in different colors based on the name column. So they all have unique values in the name column because each neighborhood has a different name. And this CMAP argument, this stands for color map. That's just to add fun colors here. There's a lot of color maps you can use, and I don't remember them. But anyway, so I just use some fun colors here. Right, so I'm plotting the name column, the unique values from the name column. Okay, so you can also symbolize any of the fields in this GeoDataframe easily. So another one of the columns is planner, and then there's a third one called engineer. So let me comment out the engineer column just for a sec, and let's run this again for planner. So let me show you what I'm doing here. Let me turn on this again, and we'll look at the GeoDataframe data. So now we're looking at the planner column, and not all these values are unique. There are a few city planners for the city of Charlottesville, and they each have jurisdiction over a few of the neighborhoods. So the first planner is Brian Haluska for the North Downtown neighborhood, Carrie Rainey for the Martha Jefferson, Carrie Rainey again for Woolen Mills, and then Dannon O'Connell for Locust Grove. So you see that there are like 4 or 5 maybe planners for the city of Charlottesville. I'll get rid of that yet again. And what I've done here back in this cell is I have plotted all the neighborhoods with the planner column. So there's 1, 2, 3, 4, 5 colors on the map. So there's 5 city planners for the city. And I didn't choose a color map this time. I just let it do whatever the default colors are. But you see all these gray neighborhoods over here. Those are under someone's jurisdiction. So not all the values here are unique. And then the same thing for the city engineer. I think there's only 2 of these. Yeah, so one half of the city gets one engineer. The other half of the city gets the other engineer, just like that. So there's only 2 city engineers. And yet again, I'm going to convert our coordinate reference system of the neighborhood to the same as the other roads and city boundary layer. Okay, so let's talk about intersections now. Okay, so we're going to see how how our layers interact or intersect with each other, I should say. So we're going to do some sort of pandas type stuff as well in this. So I'm going to make a new layer first that is just the Woolen Mills neighborhood. So if you're not familiar with Woolen Mills, this is over by Riverview Park, sort of on the east side of town. Okay, so what I'm doing, I'm using the exact, like I said, I'm using the exact same methods I would use in regular pandas to extract the data that I want. So I'm making a variable called Woolen Mills, and what I'm doing is I'm locating things from the neighborhood's data frame or GeoDataframe. And what I'm doing is I'm locating the neighborhood that has a name of Woolen Mills. So basically it's got this value in the name column. So there's only going to be one of these. Then I'm converting it to a different reference system, and then I'm plotting it. So let's run this here. So the first thing I did, this is the first plot, and this is not so interesting. It just shows you Woolen Mills, but not with any context. But then what I did, I plotted Woolen Mills over the base map of the city of Charlottesville boundary, and I colored it red. So you can see there, this is where Woolen Mills is, and now it's easily visible. So this is getting a little more interesting here, where first of all, we did some normal operations like you would do in pandas to separate out some data that you would want to work with. And then I plotted them on top of each other. So this is a pretty common thing you might do. You might select a subset of your data and then see how it looks versus the rest of the data. That's a pretty common thing to do. And now in the next cell, what I'm doing is I am selecting out the roads that are in woolen mills. So I'm using this overlay operation here. So basically what I'm doing, I'm looking for the roads that intersect woolen mills. So you see how equals intersection. So there's a bunch of different spatial operations here of how objects can relate to each other. You can look at objects that are completely within other objects. You can look at objects that intersect with other objects. You can look at ones that do not intersect. So you can do like the opposite here. There's various ways that these objects on the map can relate to each other. I won't go into all of them now. But you'll see what I've done here is I've selected out the Woolen Mills roads and Woolen Mills, and I have plotted all the roads in the city of Charlottesville over the normal base map. And then I've selected out Woolen Mills roads and also the Woolen Mills neighborhood and plotted those separately in different colors also. So that's another common thing you might do. Again, I'm selecting out a subset of my data frame, and we're doing this spatially here. So earlier, what I did, this is normal pandas. So I'm looking through the data in the column, I'm looking for, columns where the row value equals Woolen Mills. Well, this is something you could not do previously just in normal pandas. Pandas does not have a geospatial or geometric overlay operation like this. So I'm selecting roads that intersect with Woolen Mills. And I made another layer called Woolen Mills Roads. And then I just plotted all of these later. I plotted the Charlottesville boundary as we saw earlier. I plotted the roads, I plotted Woolen Mills, and I plotted the Woolen Mills roads. Just like that. So that's something that previously, before GeoPandas, you'd have to do in another program of some kind, like ArcGIS or QGIS, PostgreSQL, etc. So another thing you might want to do is create a buffer. So buffer is basically just a boundary outside of something. And this is another common geospatial operation. So I'm importing a few different layers. I've got cemeteries in the city of Charlottesville. And again, this is a GeoJSON layer. So this is a different data type than we've seen earlier. Basically, it's just structured text, as I said earlier. The difference between JSON, which you may have seen before, and GeoJSON is that GeoJSON preserves the spatial characteristics of these objects. So these cemeteries are shapes. There's a couple cemeteries in the city of Charlottesville. Basically, that GeoJSON file has the outline of the shapes within that. And it's characterized as latitude, longitudes. Okay, so what I've done, let me show you what I've done here, and then we'll look at the code to do it. And I'm using that contextually again, so it's giving me an error, but it still should plot these things. So this is annoying. It's not showing like where we are in Charlottesville, but this is the north downtown. Like the downtown mall is kind of like, well, I guess it would be like right through here, more or less. This is the north downtown cemetery, and this is the one that's off of Emmett Street, or Elliott Street, I should say. Emmett turns into Elliott. But anyway, these are the two City of Charlottesville public cemeteries. And what I've done is I've created a buffer around them. I think this is a 1/4 mile buffer, which I'll verify that later. So let's see how I did that earlier. The contextually is, again, not working right, but that's annoying. Okay, so the first thing I did, I imported my cemeteries layer. I converted the coordinate reference system. And then I created a centroid point for the cemetery. So what is a centroid? I scroll back down here. Basically, it is the center point of this object. right there in the middle. And you can just do that with one simple line of code. So cemeteries.centroid, and it creates a new column in the GeoPandas GeoDataframe that's called centroid. So then I made a buffer column. And what I've done is I've made a 1/4 mile buffer around each cemetery, or around, I guess, the centroid of the cemetery. So what I've done is I've used the buffer method. And this is where the coordinate reference system is important. So we're measuring things in feet. So 1,320 feet, that is 1/4 mile. So a mile is 5,280 feet divided by 4 equals 1,320. I probably should just be using kilometers and meters and stuff, but my apologies. So anyway, I've created a new buffer column and renamed it to cemeteries buffer. So what I've done here is then created another plot. I've made the cemeteries buffer in the background. I plotted the cemeteries, and then the base map is not working. Actually, if I think if I comment this out, it should be a little cleaner to look at. There we go. So again, the cemeteries are overlaid on top of the buffer, and I made them slightly see-through as well. So that's just one example. So just off the top of my head, an example of why you might want to create a buffer or something like that. So let's say you wanted to select, you wanted to find all the houses within a 1/4 mile or 1/2 mile or 5 miles of a cemetery for some reason. Well, you could do exactly this, and then you could run the intersection that we did earlier to get these Woolen Mills roads. You could do the intersection of all the houses within the 1/4 mile buffer of your cemetery. So exporting files, I'm actually not gonna, I will do this. You can export these files in many different formats. So we just got a to-file method here. And basically we're just gonna export this to the desktop. So I'm just exporting the roads layer just as an example here. So what I'm doing is I'm creating a GeoPackage layer. And GeoPackage, I don't think I've talked about yet. This is another common spatial object, or a spatial data file type, if you will. I've created a new layer. I just called it my new layer. And long story short, these arguments are required for the driver, like the file type it's going to be, the layer name. That's if you're going to use it in a GIS program. And then the path to where this file will be saved. So let's run that cell there. And then if I go on my desktop, oh yeah, so there it is. I created a new layer, Cville GIS data, new geopackage.gpkg. So, right, so the file is called new geopackage. And there it is. I'm just going to delete that because I don't really need it. But you can do that. Okay. So now we're going to go in a different direction here and use Folium. Okay, so I briefly mentioned this earlier, but Folium is another Python mapping library built on the popular Leaflet JavaScript library. So now we can make nice web maps in Python instead of in JavaScript. And the strength of Folium is in its mapping capabilities. So this is not a data manipulation library in the way that GeoPandas is. Here are the documentation. And you can see here it says, manipulate your data in Python and then visualize it in a leaflet map via Folium. Okay, so these look really nice. So previously we've been mapping things, or plotting things I should say, just on basically MatPlotLib. But Folium makes these look really nice. So in this section of the code, I'll be using data from the city of Richmond's GeoHub, which is basically the same, it's the equivalent as the city of Charlottesville's data hub that I showed you earlier. Again, they have freely available data for the public to use. So that's what I'm using. So I'll refer to the Folium documentation as I go. And I've got a note here that basically I've taken these examples straight from the Folium documentation with very slight modifications. Okay, so in step 14, if you are a JavaScript user and you've used Leaflet, this is beginning to look familiar. If you've never used it before, then don't worry. You'll pick up on it. But let's see what this looks like here. So we have a base map, which is what I was hoping to get using Contextily earlier. But the difference here is that this is dynamic. I can move this around. This is OpenStreetMap imagery. So this is like live on the web, what you're seeing there. It scales as I zoom in and out. So that's what you commonly see when you're using Google Maps or OpenStreetMap or whatever. And now we can do it in Python, which is really, really nice. So what I've done here is again, this is mostly just straight from the documentation. I've made a variable called m, and I have mapped it. So the location, this is the latitude, longitude of Richmond, and the zoom start, that's the zoom level that you'll see here. So if I do, I think it goes from 1 to 20. So if I do zoom level 5, you see it's zoomed way out. If I do zoom level 15, it's zoomed in a lot closer to a neighborhood in Richmond. So I'll just go back to 10. Okay, so let's add some data to the map. So we can use all the same kinds of data that we were previously using, and then some. So what I'm doing here is, you see here, I've got a variable called Richmond Libraries, and then I've got this long URL, basically. So if I go here, if I copy and paste that and then put it in my browser, it is giving me data about all of the Richmond libraries. These are like the public libraries in Richmond. And this is somewhat human readable. So Broad Rock branch, Hull Street branch, Main branch, Belmont branch. It's got the latitude, longitude of that data. It's got a little bit more information as well. But the point is that here I am using a web service. So the city of Richmond has put this online for anybody to use. So previously I had downloaded the data. So it's like static data. It's physically, I physically downloaded the files. This is being streamed from the web from the city of Richmond. So let's say they built a new branch library. Well, that would automatically pop up on the map. So what I've got here are little, pop-ups for all the branch libraries in Richmond. Like I said, because I'm streaming this data from a web service, if they built a new branch library out here, there would be another dot on the map. So the way I did this, again, I did the same setup for my map as I did earlier. And then I added, so basically from the Folium documentation, I followed how to add a layer. In this case, the layer is a GeoJSON layer. And then I added it to the map. And then displayed it on the map there. Okay, so this is starting to be pretty cool. This is a little more dynamic. So I can zoom in on these things here. But there's still nothing happening when I click on the dots. But it is showing them on the map, so that's cool. Okay, Choropleth maps. So this is getting into the weeds with map or cartography vocabulary here. So let me show you what I've done here, and then we'll talk about the code. And I should say this code I lifted directly from the Folium documentation. I don't think I changed this at all, but let's look at it first. So a Choropleth map is basically just a map with shading that's on a graduated scale. So this is, I don't think this is, it's not labeled or anything, But this is showing US unemployment rates in October 2012. So yellow is a lower unemployment rate, and then dark green is a higher unemployment rate. So you see the scale, and it ranges from like 3% unemployment to over 10% unemployment. So some states have higher rates of unemployment. North Carolina is relatively high. Nebraska is low. California and Nevada are high. And all the others are somewhere in the middle. Okay. So again, I didn't write this code myself, but first of all, we're reading in a data set. And in this case, the data is on a Github page. We're reading in the data. We are making a map again, and then folium.choropleth. So the rest of these arguments here are just styling the map. So we've got our data in there. So the name is Choropleth map. We've got legend names and labels. So you see here unemployment rate, percentage. These are the opacities of the shapes and the lines, the fill colors, yellow and green color scheme, things like that. So I don't honestly know that much about all these arguments. Just know that I copied this, that you can do it. I copied this example from the documentation. Okay, so now we're nearing the end here. Yeah, and we're gonna bring it all together. So we're gonna put together GeoPandas and Folium. Okay, so step 17. We can plot using GeoPandas GeoDataframes and similar objects. So what I'm doing here, again, this is going back to the data that's in our Seville GIS data folder. So this is called Volcano Data 2010. So this is just a CSV file, as you have seen before, I'm sure. So I'm reading in the volcano data, and then I'm cleaning up some of the data. I'm keeping only the relevant columns that I care about. And then I'm plotting the volcano data. So these are for 62 volcanoes around the world. So it's got I'm not sure if this is the year the data was collected or the year of the last eruption. I honestly don't know. But it's got the name of the volcano, the country it's located in, the latitude, longitude of it, and then the type. So there's different types of volcanoes, stratovolcano, complex volcano, etc. Okay, so now we're going to create basically our geometry column from the latitude longitude column of the volcano data frame. So you see latitude longitude here. We can use those to create a geometry column, which I'm going to do here. So again, this came from the GeoPandas documentation. So what I'm doing is I'm doing GeoPandas points from XY, and then I'm using the latitude longitude of latitude longitude columns from the volcanoes layer to do this. And then I'm creating a new column called geometry, and then I'm just displaying it. So now we've got a geometry column. We have latitude, longitude. These are now in geometry, like that. Okay. So the last thing I'm doing is plotting this. Let's see. Oh, so I guess I'm doing this in stages here. I'm just making another map of the world, which I will later plot the volcanoes on. And now I'm making markers for each volcano in the Folium map. So again, if you're used to JavaScript, this looks very JavaScript-y, especially if you're used to using Leaflet library. So let me show you what I've done here, and then we'll go back through the code a bit. So what I've done is I've got my map, and then I've got these pop-ups for all volcanoes in the world. Or these probably aren't all the volcanoes, but at least all the volcanoes in my data set. So this is not beautiful, but this, you see here, it says the name Yellowstone, the country United States, it's a caldera volcano, and then the coordinates of it. Over here we have Katla, the country is Iceland, it's a subglacial volcano. Over here we have Nabro in Eritrea, stratovolcano. Okatina in New Zealand, Lava Dome volcano. I don't know my volcano types very well, but you get the point here. So what I've done, we've got an interactive map here with these labels that you can interact with. And I could do a lot more with these. These are just pretty basic. But let's talk about the code a little bit, what's going on here. So again, I lifted this from the documentation, so I did not write this myself, but to explain it a little bit better. So I've created a geometry list from the GeoDataframe. So what I've done here is just created a list of all the points from the volcanoes.geometry column. So basically if I scroll up here, we've just got a list of these points. That's all that is. Okay, so now I'm looping over each one of those points. So there are 62 volcanoes in my data set, and I'm looping over one of those. So for each one of these coordinates in the list, I am I'm basically like making the marker, or actually this first part is I'm assigning colors. So if the type of the volcano is a stratovolcano, it gets green. If the type is a complex volcano, it gets blue. And so on. If it's none of those, then it gets a purple marker. So then we are adding these markers to the map. So again, this is very like leaflet-esque. But what I'm doing is so this information here, this is the information that you'll see in the pop-up. So instead of year, I could say something like year of eruption. So let's run that again. If I click on one. So year of eruption, this is Kilauea volcano. So this is being rendered dynamically on the map. And don't worry too much about this stuff. This is just filling in the values of all these volcanoes. Okay, so again, I know that was complicated code, but I just want to give you an idea of what you can do. And you could figure out how to do that later, or you can ask me for help in the future. Okay. So I'm going to go back to the GitHub repository, and at the bottom of the page, I have a self-help section. So one of the biggest takeaways of these workshops is that you can always ask for help in the future. You can always ask me. I have my contact information here at the top of the page, eperper@virginia.edu. And I just wanted to show a little bit of self-help real quickly. So ChatGPT has come into being as of November 2022, I think it was. And it is a hugely powerful tool if you use it the right way. So I want to give you a caveat that I use it a lot, but that doesn't mean you don't want to trust it blindly. So in my personal opinion, it's not a substitute for learning how to program. And you always need to double check the code that ChatGPT gives you. Never accept it verbatim. So I'll show you real quickly like what I would do if I was struggling to work with Pandas Dataframes or GeoPandas, GeoDataframes, stuff like that. So I'm going to include a link to ChatGPT as well in the video notes. Now let me go back. So I'm going to ChatGPT 3.5. This is the free version of ChatGPT. So for example, can you show me how to create a GeoPandas GeoDataframe in Python? So let's see what it gives me here. So it's going over some background info what you need to do, import the proper libraries, create a Pandas data frame with your data, convert that to a geometry object, and so on. So they're giving you some sample code here. So they just created a sample data frame for a few different cities. They've made a data frame out of it. They've created a geometry column and then created a GeoDataframe out of that. So let's say, for example, I didn't understand one of these lines. So create a geometry column with point objects. Let's say I didn't understand that line. So ChatGPT does have some memory, so you can reference your previous questions in the next one. So this is not a, I see what they're doing here is they're like zipping the latitude and longitude columns together. But let's say this is not really a GeoDataframe question, but let's say I wanted to follow up on that. I don't understand the line where you created the geometry variable. Can you explain that some more? So you see I'm talking to this basically like I would talk to a person in a way. So it's saying, certainly in the code snippet above, geometry is created by iterating over latitude and latitude, etc. So it's showing you the line, and then it's going further into detail. It's talking about the zip function. That has nothing to do with GeoPandas. That's a built-in Python function. So it's explaining that some more. But let's talk about like, a GeoPandas question, for example. How does a Pandas data frame differ from a GeoPandas GeoDataframe? So they're talking about how these data structures are and what the differences are. I mean, basically the difference to me is that the GeoDataframe has a geometry column, which they reference there. They're talking about some capabilities of these and so on and so forth. So you can see here how this might be useful. Like if you were struggling to, let's scroll back up here. Like if you're struggling to use the overlay function, you might ask a question about that. You could ask like, how do I make my figure bigger? What are all the colors available to me for these layers, et cetera, et cetera. So I found ChatGPT to be a hugely helpful tool when saving time. Another example of that is, so I don't use GeoPandas or Pandas for that matter every day. I know there's a lot of things you can do in it, but I don't remember all the syntax for exactly how to do that all the time. So it's really helpful to ask ChatGPT, like, how do I do this? But the key here is that I know what I'm going for. I'm not asking blindly here. I know generally what it should look like. I just don't remember all the specific syntax for maybe creating a Pandas data frame, or like how to zip all these latitude longitudes together and things like that. So like I said earlier, ChatGPT is not a substitute for programming. It is a complement to it, if you ask me. Okay. So I've got a few other links here to some of the documentation pages that I referenced earlier for the various libraries. But all in all, that's what we've got. That's what I've got for you today. So in conclusion, thank you all very much for attending. If you've got future questions, please reach out to me. Otherwise, have a good day.